At the exact moment the interstellar visitor atlas should have been scorched, shattered, or spectacularly revealed by the sun, it vanished from our view, sitting perfectly hidden behind the star. What happened to Atlas at perihelion, and why does that single missed instant now have astronomers whispering about something far stranger than a comet? 3i Atlas showed up in mid-2025 and immediately refused to behave like a normal comet. Discovered by the Atlas survey, it's a true interstellar visitor, one of only a handful ever seen, and already notable for its size and strange signatures. Estimates put its nucleus on the order of kilometers across. Loeb and colleagues have suggested a minimum diameter of a few kilometers and a mass in the billions of tons, which makes it vastly larger than the tiny interstellar interlopers we'd seen before, and big enough that any odd behavior matters. Scientists quickly noticed unusual color changes, unexpected jets, and odd spectral lines details that turned this from interesting comet to object that demands scrutiny. Avi Loeb and other researchers have been public and vocal about these anomalies, arguing they pile up into a pattern that's hard to dismiss. And that's exactly why missing the perihelion moment was so painful for observers. On October 29, 2025 at 7:47 a.m. Eastern, JPL Horizons and researchers like Avi Loeb pinpointed Atlas's perihelion with minute-level precision, exactly when the sun's heat on the object peaked, about 770 watts per square meter. Atlas was sitting directly behind the star from Earth's perspective. That timing turned what should have been the most revealing moment into a blackout. Ground telescopes were blind, and the most dramatic thermal and mechanical stresses played out of sight. If Atlas is held together loosely, that surge of heat and tidal stress is exactly the sort of event that could shred it, producing fragments and a sudden, spectacular plume we never got to watch up close. Instead, we've been left with indirect clues and a nagging question. Did something dramatic happen while the cameras were off? Imagine Earth had been on the opposite side of its orbit. Atlas would have swept within about 54 million kilometers, close enough for existing planetary radar to image its shape and rotation in detail. Instead, our geometry left us with a very different reality, even at its closest approach to Earth. Later this year, it will still be roughly 269 million kilometers away on December 19, 2025, far too distant for useful radar mapping. That missed window matters because radar does something light cannot. It builds three-dimensional models and measures size directly through multiple passes over a rotation period. Without it, we're forced to infer shape and mass from light curves and spectra, useful but indirect and ambiguous. So instead of crisp radar frames, we got a thought experiment. What would we have learned if the timing had been different? The answer is blunt. Enough detail to settle debates about size, fragmentation, and even whether any surface structure exists. Instead, we wait for optical and infrared observations and hope the data they return can carry the weight of what radar would have shown. When scientists mapped Atlas's trajectory, one detail immediately stood out. It wasn't random. For an object arriving from deep interstellar space, the odds of it lining up neatly with the ecliptic plane, the same flat plane where all our planets orbit, are tiny, less than 0.2%, according to Avi Loeb's analysis. Yet Atlas glides almost perfectly along that path, as if it somehow knew the layout of our solar system before it arrived. Then came another surprise, its speed. Most large interstellar objects travel more slowly because of gravitational dynamics in their home systems. Atlas breaks that rule. It's unusually massive and unusually fast, a combination that defies natural formation models. And the coincidences don't end there. The object's course takes it unnervingly close to Mars, Venus and Jupiter, hitting those alignments with near-surgical precision. Even stranger, its trajectory placed it perfectly hidden behind the Sun from Earth right at perihelion, the one time everyone wanted a clear look. The probability of all these events stacking together by chance is vanishingly small. To many in the scientific community, it doesn't look like a random traveller anymore. It looks more like something navigating a carefully plotted route through our neighbourhood. Once telescopes managed to analyse Atlas's spectral fingerprints, the results left scientists stunned. The gases streaming from the object contained far more nickel than iron, an industrial-style ratio almost never found in nature. In fact, that metal balance resembles processed alloys more than raw cosmic material. On top of that, Atlas showed only about 4% water by mass, a figure wildly out of line with what defines a comet normally 80 to 90% ice. That means this thing isn't a frozen snowball, it's practically dry and metallic. Even its light behaves differently. Its polarization, the way light waves reflect and twist off the surface, was unlike anything seen in known comets. Add to that an anti-tail observed earlier in 2025, a jet streaming toward the sun instead of away from it, defying basic solar radiation physics. Each one of these anomalies might have an exotic natural explanation, but together they make Atlas feel like it's operating on its own rules. If Atlas is technological, and that's a big if, there are certain clues that would make it undeniable. Scientists are scanning for tiny course corrections, deliberate movements that can't be explained by outgassing. They're also monitoring for radio emissions, looking for any signal with a pattern too organized to be random cosmic noise. Thermal instruments are watching for heat excess that could suggest propulsion or internal power. Some even suspect Atlas might release mini-probes, small fragments that move independently before drifting back into the dark. Around the world, observatories have shifted to near-continuous tracking, trying to catch even a flicker of these telltale signs. And though nothing definitive has surfaced yet, the silence doesn't make things simpler. It just deepens the mystery. If Atlas is a natural comet, we'll likely see it break apart from the sun's heat in the coming months. But if it doesn't, then we may be witnessing something far beyond anything we've encountered before. The strange behavior of Atlas hasn't stayed confined to observatories, it's spilled into the public eye. Congresswoman Anna Paulina Luna has stepped in, pushing to release the high-resolution high-rise images taken back on October 2nd, 2025, which could show the object in detail before it slipped behind the sun. Avi Loeb has publicly supported the move, urging transparency so independent scientists can analyze the data. Behind the scenes, there's tension. Government agencies are cautious, citing data validation protocols, while astronomers argue that every lost day means losing the chance to catch Atlas before it changes again. Online, the mystery has already gone viral. Rumours swirl, theories multiply, and the call for the truth about Atlas grows louder. The story has outgrown astronomy. It's become a global question of curiosity, secrecy, and whether we're finally glimpsing proof that we're not alone. Now all eyes are on December 19th, 2025, the date when Atlas makes its closest approach to Earth, skimming by at a distance of roughly 269 million kilometers. That might sound far, but for astronomers it's close enough to launch an all-out observation campaign. The James Webb Space Telescope, Hubble, and some of the world's largest ground-based observatories are already scheduled to track the object. Scientists plan to capture its light curves, map its thermal signature, and search for any irregular pulses or bright flashes that might hint at internal activity. If Atlas is breaking apart, we'll see sudden brightening or a fan of dust. If it's maneuvering, its motion will defy gravity's prediction. Either way, the next few weeks could decide whether Atlas becomes another footnote in cometary science, or the most important astronomical discovery of our lifetime. And even then it might not be enough. The distances are vast, the viewing windows short, and data transmission slow. It's possible that by the time we piece together a full picture, Atlas will already be gone, leaving only fragments, streaks of gas, or perhaps nothing at all. But scientists are relentless. Whether through reflected light, radio silence, or the faintest signal from deep space, they'll keep listening. Because if Atlas isn't natural, then every bit of information we gather could rewrite what we think we know about intelligent life beyond Earth. Here's what it comes down to. Atlas shouldn't exist the way it does. Its path, its chemistry, its behavior, they all break the rules of what we know about comets. Maybe it's just a freak of nature, a once-in-a-trillion cosmic coincidence that slipped through the cracks of probability. But maybe it's something more. If it turns out to be natural, it will still challenge every model of how interstellar matter behaves. But if it's not, if it's engineered, then we're witnessing proof that we are no longer the only ones building machines that move between the stars. Either outcome changes history. So the next time you look up at the night sky, remember this. Somewhere out there, Atlas is moving silently through the dark, holding secrets we may not be ready to understand. The question isn't just what Atlas is, it's who might have sent it.